Assalamualaikum students. This is week number 14 and we are going to discuss a very important type of random variable which is called normal random variable. This is basically a type of continuous random variable which have certain parameters, and by changing those parameters we can get different shapes. So today we are discussing a normal random variable which is also called Gaussian random variable or bell curve random variable because of the shape of the PDF of this random variable. So why is this called a normal random variable? Because it is used very frequently in many situations, and hence because of this reason this is also called normal random variable. So let's move on and see what is this and what are the properties, what are different parameters, and what are different uses, what are different applications where it is used. So the first thing here is that you can see the shape of this random variable. Actually these are the slides of Abu Bakr Sahab. I am using those slides. He has used these figures, these handmade figures, so I am following the same lectures and same slides. So you guys may have, if you guys have any difficulty or any ambiguity, you can contact me or you can tell me in your interactive session. So this is the PDF of a normal random variable. You can see that it has certain parameters, and the first parameter it has is this mu. What is mu? Mu is the expected value or average value of this curve, and you can see that it is like a bell curve. Okay, this is like a bell. That's why this is called a bell curve random variable, Gaussian random variable, or normal random variable. Okay, X is a bell-shaped curve which is centered and symmetric around the mean mu, mean m. Okay, there is one important thing to mention here. M and mu, these are two variables which are used for denoting the expected value, but there is a difference. What is mu? What is m? Mu is used for the population mean. Okay, population mean. If you have a total population, a total values is a random variable which is encapsulating the total values or total probabilistic curve. So then we will use mu, and mu is then used for the population mean, while m is used for the sample mean. Okay, there are these two terms. What is basically a sample? I have mentioned it in our previous lecture as well, that sample is basically the subset of a bigger set. If you have a bigger set and you are taking some numbers out of that set, so the other set which has been taken from the original set is basically the sample or the subset of that original set. So the mean of that set will be denoted by this small m. So as we are basically using here the total sets or subset of the original set of the original random variable, so that's why I am using mu here. X is basically the PDF. Okay, I am using the term PDF here. I am not using the term PMF here because here we have a continuous random variable. Whenever I will use a discrete random variable, there I will have a PMF, probability mass function. I have told you guys the difference between these two. So this is a curve. You guys also have seen it in recent days when everyone was discussing the coronavirus and COVID-19 curve. It was basically this one. Okay, what is this telling you guys? You guys can see that it is applicable everywhere, in every aspect of your life. This random variable can be exploited, can be used. Okay, Just like here in coronavirus cases, initially Pakistan has lesser number of cases with the passage of the days. Okay, if this x-axis shows the number of days, with the passage of the days, the number of patients has been increased, and at one time in Pakistan, in the case of Pakistan, this time was almost 18-19 June. At this time it has reached its peak, and then after reaching its peak it has turned down to the downward position, and the curve was in the other side. The curve was, or the number of patients were in the decreasing side. So you guys can see that it is applicable everywhere. For example, in your life, you have energy and power. When you were in childhood, you have lesser amount of energy, and with the passage of your age, there you got an age in which you will have a maximum amount of power in your muscles, and after that time your muscles will be crippled, and after some time your power will be same like when you were in your childhood or infant position. So this is applicable everywhere. Just see, and it will be applied. Okay, so there are basically, in this random variable you have two parameters. One is mu, which is called the expected value. We have discussed it, and the other parameter of this random variable is basically called sigma, or sigma square, or this is also called variance. Okay, what is variance? As the name suggests, it tells you the variability, or it basically shows the variability in the width of the curve. If this is the dispersion or width of the curve, then this is denoted by this sigma square. Higher variance means higher dispersion rate or higher width of a curve. If you have two curves, one is like this one, and the other one, this is like this one. So this curve, if both of them, you can see that both of them has zero mean. This has zero mean. This curve also has zero mean. But if you guys observe the variances of these two curves, the variance of this curve is lesser if variance of this is represented by sigma 1 square, and variance of this is represented by sigma 2 square. So you guys will see that the variance sigma 2 square is greater than sigma 1 square. Okay, variance is represented by sigma square, and square root of the variance is called the standard deviation. Okay, how much a curve or how much a value is deviated from its mean position. Okay, this is the mean, and what is the deviation of this point from the mean. That's why if you have here x value, so this will be equal to x minus mu, and in variance case it will be x minus mu whole square, and you will take all these values, this variable dispersion of this or deviation of this from this value, you will take all these values, you will then add them, and at the end you will divide it over the mean, and then you will divide it over the total number of points, and then you will have the average rate of dispersion, and then you will get the variance of the curve. Okay, actually in any distribution you will not have a single number, you will have many numbers, and you will have to calculate the average dispersion. You will have to calculate the difference between the mean and that number. Okay, let me discuss it very clearly. Okay, let me tell you that let's have some numbers 1, 2 and 3. Okay, the distance between this and this is, it has some distance. This point has some distance from me, and this point also has some distance from the me. Okay, what are those? These points, this is basically this point, it is this point, and this one is this one. This one, and this one. That's it. These are the three numbers. These three numbers have the same mean, which is mu, but we want to calculate the variance. How can we calculate the variance? Okay, let us calculate it. So here, this is, let's say this is x1, this is x2, and this is x3. I am taking somehow longer in this slide because of the concept building. After it we will go somehow faster. Okay, so what will this distance be equal to? This will be equal to mu minus x1 plus mu minus x2 and plus mu minus x3. These are now three dispersions. We have added them, we have added the distances between them, and then if you are calculating the standard deviation, let us calculate standard deviation, which is the square root of a variance. Okay, if we have a variance sigma square, so the square root of a variance is a standard deviation. Finding the standard deviation is easier, so you will not have to square them here for finding the standard deviation. If you are finding the value of the variance, so you will have to square it always after taking the difference. Okay, adding them, and then after adding them you will have to take the total number of these points, and you will then divide it over this one, and then you will get the average amount of dispersion here in these points. Okay, and this amount, this dispersion is called standard deviation. After finding the standard deviation, you will just square it, and after squaring it you will get a variance of these three numbers. This is the variance, and it has more information than mean of a number. Okay, these are basically, there are different modes of a random variable. The first mode is called the expected value or average value. The second mode is called the variance of a random variable. So these are different things which are also called mode of a random variable. So this is a Gaussian random variable. It has, basically we are going to discuss two parameters. Actually it has four parameters. First parameter is a mean, second is a variance, third is a skewness, and four is a kurtosis. We are not going to discuss the third and fourth one. We will discuss only mean and standard deviation. Okay, so I think this concept is clear. Let's move on. So this is basically the formula or mathematical equation of a PDF of random variable. This is 1 over 2 pi square root and sigma into exponential of minus x minus m whole square divided by 2 sigma square. This is the equation which is called the normal equation, normal random variable, and you guys will use it very often, not only in this course but in the course of a digital signal processing, in the course of communication systems, and in many courses you guys will use this equation very often. Okay, so it is important to understand the concept behind this random variable. What is sigma? Sigma is basically the, again, standard deviation, and it is also written here is that sigma is the standard deviation. Okay, sigma is the standard deviation and sigma square is the variance. Again, I am telling this thing again and again, and you guys should have understood it in a very well manner. Variance, and what is sigma? Sigma is the standard deviation. Okay, sigma square is the variance. So the width of the bell shape the width of the bell shape curve increases with sigma. If you will increase sigma, the dispersion or the deviation will increase. Okay, the average amount of deviation will increase, and but the height will decrease. Okay, if dispersion or the width of the curve will increase, the height will decrease, and vice versa. If you will decrease the width of a curve, then basically the height will increase. So the average area will remain the same. The area which is coming under this random variable or this curve will always remain the same, and that is the actual region that by increasing the width, height will decrease, and by decreasing the width, height will increase. Okay, so I think it is clear now, and this is the PDF. Okay, this equation is used as a PDF. If you plot it in MATLAB, you will see that it will be a what is this? This will basically be the bell curve. Here m, what is m? What m is basically the mean value. If you are using zero mean, so the value of it will be 0, and if you are using sigma square equal to 1, so the standard deviation will be equal to 1. Okay, let's move on. Okay, normal random variable. For example, the PDF of two normal distribution with the same mean are shown below. These are basically having the same mean, but the one on the left has higher variance. You guys again can see, but these slides don't even show yet that what is variance and what is standard deviation. But I have told you guys, and I have taught you that what is the difference between standard deviation and what is the difference and variance. So this curve, you guys can see that it is high, greater width, and this is the width here is smaller. Okay, this is somehow incorrect, because when the width will increase, the height will decrease. Okay, so it has higher width but lower. This is not here, it will be from here to here, because it will have lower height than this one, because the area will remain same in both of these curves. So it has higher variance and it has lower variance. Parameter variance has a lower value here, and here it has a higher value. So that's why the curve has higher value. Okay, let's move on. The normal distribution is the most common distribution that arises in probability theory. I have told you that it is not only used in probability theory, but in communication systems, in digital signal processing, in every aspect of your life and everywhere. If it is any pandemic, if it is any disease, if you are talking about the intensity of any event, each and everything will follow the normal random variable. So that's why this random variable is very important. In continuous time, it is a normal random variable, but if you will talk about in discrete time, so in discrete time the same shape is followed by a binomial random variable. Okay, so these are basically equivalent, but in discrete time it is called binomial random variable. Okay, this is because the normal distribution is the average sum of many small random variables, and this scenario is quite common. I am not discussing it, I am not confusing you with this statement, but just stick to the upper statement, which is telling that this is the most commonly used random variable. So let's move on. For example, if we consider the PDF of the marks of 30 students from a class in the board exam, then their distribution will not be very similar to a bell curve. Okay, Why is not very similar to the bell curve? Because for a bell curve or any ideal bell curve, the amount or the number of elements or the number of people you are encompassing should be great, should be almost be reaching infinity. If because we are talking about the continuous random variable, so higher the number of the points, higher will be the resolution of this random PDF of the random variable. Okay, here we have just 30 students. 30 is not basically a very good number. Some you guys can see that I am plotting. This is basically histogram. Okay, in this histogram we are plotting different numbers. Some people are getting this is basically, what is this bar equal to? This is showing basically the number of people who are getting numbers which ranges between 800 to 900. If this is 870, so this bar shows you the number of people who are getting marks 870, and these are the people who are getting marks 900, and so on. These are the people who are getting marks equal to 1000. Okay, so these are basically different numbers of 30 people which is plotted here, but it is not basically showing you a very good resolution random variable. Okay, so what we have to do, we have to increase the number. We have to now increase the number of points, and by increasing the number of points, you guys can see that the resolution of a random variable, normal random variable, will also increase, and you will get a very smooth curve then. Okay, let's move on again. So the distribution of the marks of all students appearing in the board example will be the sum of many such videos and will somewhat resemble a bell curve. Now you guys can see that all the students in the board exam, the number of students appearing in a board exam is higher than 30 students out of a class. So if you guys will plot it, you will get a very smooth curve which is shown here. Okay, we are on x-axis. You are basically plotting the marks of the student, and at y-axis you are getting the number of people who are getting these marks. From these you also have the total number of people. You have the number of people who are getting specific marks, so you guys can also calculate the probability of getting any amount of marks. Okay, so let's move on. The age of human being will also form a normal distribution because it also encompasses all the human beings on earth. Okay. Now basically up to 7.5 billion people on earth, and this is very huge number which encompasses from 0 to 106 or 120 or 130. We don't yet know the exact age of the oldest person on earth. Some people say that it is 106, but I have doubt in it, because our country, Punjab, is the region where where the age of 100 is very normal. Okay, you guys should research. You should search this thing, that the age of 100 is very normal at Punjab and other hilly areas or northern areas of our country. So I have some doubt in it, because the age of those people are not on the record. The age of human being will also form a distribution. A very small percentage of human will die very soon, and a very small percentage will die very late, while the vast majority of people will die around the mean and say around 60 years. Okay, around this means the people will die, and the age expectancy is very low after it, and most of the people are there. And the average age, if the average age is 60 in a globe, so you guys can see that this is the average which we, okay, so this is the average age which we have, and it has some dispersion, and dispersion is also represented by the standard deviation, or you guys can also call it the variance. Okay, let's move on. Okay, normal random variable in voltage, or in many scenarios when you guys will discuss noise, which is very prominent in all communication systems, and you propose many strategies, you will see that in communication systems the most important thing and the biggest enemy is the noise in the air or in a communication media. You have to reduce it, you have to remove it. You cannot remove, basically you cannot remove it, because the noise is a random variable and it is always modeled with this normal curve. Okay, noise is almost represented by this curve, which is a normal curve, and it has, if you see it in a time series, you have plotted in with respect to time, you will see that it has some random structure which is always here to corrupt our signals. Okay, this is another very important application of this kind of variable. Now, normal random variable has some very important properties, and I'm not going to discuss this slide before diving into this slide. I'm going to discuss this slide. Okay, what is this slide? Basically this slide shows you that for a one standard deviation, if this is a one standard deviation, it basically encompasses, or it basically consists of 68% of the total numbers. If you are having 100 numbers, so within this one standard deviation, this is one standard deviation, you will have 68 numbers. Okay, this one standard deviation is very important. You can see that it will have 68% of population. If you increase it up to the two standard deviations, this is m minus 2 sigma and n plus 2 sigma. These are basically the two standard deviations. I am using a red here. Sorry. This is now a two standard deviation region. So here you will, this standard deviation, this two standard deviation basically has 95% of the overall population. And if you are trying to discuss the three standard deviations, okay, this is m minus 3 and m plus 3. These three standard deviation will almost have 99% of the overall population. Okay, so this three standard deviation will consist of the almost total amount of population. It will have almost the total amount of population within three standard deviation. So this is the point which is discussed in the previous slide. So before discussing all those mathematical formulas and all those mathematical things, it was very important to discuss this figure, because after going through this figure, all the things will be clearer. Now discuss this one. Since the normal is symmetrical around the mean, it turns out that approximately 68% of the values lie within one standard deviation of the mean. Okay, this is now very clear that if you are going to discuss, if you are going to see that what is the probability of that x lies between m minus sigma and m plus sigma. You guys can see that Abu Bakr Sahab has removed mu here, because there is a difference between m and mu. We are talking about now the sample mean. Okay, we are not talking about the population mean. Everywhere here we will talk about the sample mean. M is the sample mean. So m minus mu, x ranges lies between m plus mu, m plus sigma and m minus sigma. So what is the probability? It will encompass almost 68% of the population. Okay, it is clearer. Similarly, in interval m minus 2 sigma and m plus 2 sigma, you will have 95% of the total population. and in population in the area where you will have 3 standard deviations m minus 3 sigma and m plus 3 sigma, you will have 99% of the total population, or the total number will be included will be the 99%, 99.7%, which is almost 100%, and which will consist of all the points. Almost all the points will be here. Okay. So these slides are very important. We first discuss this one, and then we discuss these two ones. So what is the formula? This is again the formula which we use. This is the formula which we used earlier, but in many situations this formula is not used. We used another distribution which is called Z distribution. But why we use this Z distribution, it will be very clearer after we will move to the next section, and we will discuss it in this section that why this is very important. So when we substitute this Z with x minus mu divided by sigma, so the distribution we will have this form. Okay, you can see that f capital X Z is equal to 1 over 2 pi sigma exponential of minus half Z square. Now what is this? This is called Z distribution. Okay, this is a Z distribution, and why is it used? Because the Z distribution is a specific kind of Z distribution with a mean of 0 and a standard deviation of 1. This is very important. You should remember that whenever we will talk about the Z distribution, it will always have 0 mean and 1 standard deviation will have a value of 1. Standard deviation has a value of 1, and we square it, so then the variance will also have a value of 1. So both has the same value, and that's why this Z distribution is used, because it has a built-in table. You don't have to calculate all the values by using this difficult formula. Z distribution has a built-in table. Whenever it will be required, I will provide it to you guys. Okay, so it has a table. For that reason, this Z score is used. Note that the value of Z, also called the Z score, is the number of standard deviations from the mean. Okay, the Z distribution is at times referred to as the standard normal distribution. Why is it called standard normal distribution? Whenever you will see the term 0 mean and 1 standard deviation, this is called a standard normal distribution. Standard normal distribution has always 0 mean and standard deviation of a value 1. You should always keep it in your mind. Okay. So normal random, in any normal random variable, this is symmetrical, and if it has 0 mean, okay, in Z distribution it has 0 mean and 1 standard deviation. The mean is 0 and 1 standard deviation, so 50% of the points will lie here and 50% will lie here. Now here the value after it, the value of Z is greater than 0, and here the value of Z is lesser than 0. So that's why this curve is used. This is again a bell-shaped curve. Z distribution curve is also bell-shaped curve, and this is a standard normal distribution. Okay, let's move on. Okay, why is this important? Why is this standard Z table Z distribution is important? Because I have told you earlier that for using it, you don't have to calculate all the values by putting values in a standard formula which we have discussed. You just have to get some values, and after getting those values, you have to search those values in this table. This is a Z table. Okay, these two are basically the Z table. You just have to find the relevant values of those Z values, and you will get the answer. Okay, how to calculate it, I will show it later on in our example. Okay, if you search it over the internet that what is a Z table, it will show you the table, and I will show you how to calculate the values of random variable, normal random variable from this Z table. Okay, so let's move on. This is what is this? If you have the values, Z has a value lesser than 0, so So the area will have a negative z values, while the values which are greater than 0 will have positive z values. Okay. So these tables are the less than cumulative tables, as they have the left tail of the distribution shaded. Okay. So this is a very good example. After solving this example, you will understand the significance of the table and why is it used very often. So what is the statement? Scores on an exam are normally distributed with a mean of 65. Okay, sample mean or mean is 65 and the standard deviation of 9. Standard deviation is 9 and mean is 65. Find the percent of the scores which are less than 54, at least 80 and between 70 and 86. We have to find the probability that the scores are less than 54, at least 80 or between 70 and 86. You have to find these three options, that what are the values of these three. So how to find it? We have and we know that we have a normal distribution. Okay, we know the formula. We have what are the parameters of a normal random variable. Those are mean and standard deviation, which are also given. So now we can easily use a normal random variable, but it will be very difficult to use the actual equation of a normal random variable. So we will use z table or z random variable. So here you can see that mu is 65. This is not basically mu, this is basically m. Sigma is 9. Scores on exam are normal distributed. Okay, so in a first you want to find out that the values are less than 54, so x is 54. You know that the value of z is x minus mu divided by sigma. You have to put the values, and after putting the values you will get z equal to minus 1.22. Okay, this is the value of z. And now what you have to do, you have to find the probability that after it, what you will have to do, you have to find the probability that the value of z is less than minus 1.22. Okay, or if you have a bell curve, this one, and this minus 1.22 lies here, minus 1.22 lies here, you have to find this. This is the probability of all the events that z has the value less than minus 1. Okay, you have to find it. So how would you find it? This is a very important step. How to calculate it? You have to go to the table, and in this table you have to find the value of minus 1.2, and as you have the value of minus 1.22, so it doesn't have a value more than 2 decimal points. So here you will have 1 decimal point, and after it you have second decimal point. Here you will have to see that 1.2 plus 0.02 gives you minus 1.22. Okay, these are the values written here and here. These are the pre-written values. You know the value minus 1.2, and you should have to find the other decimal point, that when you will add this value with that value, you will get minus 1.22, which is the z value which you have found earlier. So by seeing this row and this column, you will see that the value you will get is 0.11112. Okay, this is the value. So this is the value, this is the required value which you will get from the table. Okay, so you will see that what is the probability of x is less than 54, or in alternate form you can see that what is the probability that z is minus 1.22, and we have found it from the table that this is point 112, and this method is very easy. Okay, you can also see that this is the same curve which I have plotted earlier on in this lecture. Okay, in previous slide I have plotted it in the previous slide. So you guys can see that this method is very easy. Instead, if you will use the same values and put it in the actual equation, that method will be very tedious and very time consuming, because you have to calculate all the values manually. So to combat this effect, the G table is provided, and from the G value you can find all those things. Okay, so this is the first answer, that the score is less than 54. What is the probability that the score is at least 80? Okay, what is mean by at least 80? That the score should be equal to or greater than 80. It is, you guys can see that it is showing that the value is greater than or equal to 80 is always equal to the value greater than 80, because it is a continuous distribution. You cannot separate different points. So these 2 points are almost similar. So how would you calculate it? Again, the same procedure. You have mu65 sigma 9, and now the value of x is 80. Put these values here, okay, and you will get the value z 1.67. You have in the table, you guys will have, okay, by seeing in the table. Let me change the color of this fan. Okay, in the table you will see the 1 decimal point, what is 1.6, and the other thing or other point I should add with it, and I get 1.67 will be 0.07, and by the correlation of this row and this column, I will get 0.9525 value. But what is this value? I have told you guys earlier that if we have a curve, Z curve, and it has this shape, okay, this is the shape. So this Z value will lie almost here. This is the value which is 1.67, and whatever you calculate, you find the probability. So this probability will always have these values, that what is the probability that the value lies at at 80 or 1.67 or less than 1.67. If you want to find out the higher value, what will you do? You will subtract it from what? From 1. This overall is 1. You have to find this one. You don't have to find this one, because you are asked to find the value which is at least 80. You have to find the value which are greater than 80. Okay, you don't have to find the values which are less than 80. So we have to find the probability, or this area, we have to find this area, this white area. So we have to subtract it from 1. So 1 minus probability that x, or sorry, z is less than 1.67. Okay, after finding the value, I will subtract it from 1, and this is also depicted in this line, this one. In this slide, it is also shown that you have to subtract it from 1, and after finding it, you will see that the probability of getting marks less than 80 is 0.0475. Okay, I think this is 0.475. There is some issue here in these values. So you guys can see that this is this area. It is this area which you want to find, and I have told you why do you have to find these values. Okay, let's move on. Okay, what is the last thing? That the last thing is that you have to find the value that what is the probability that the student gets marks between 70 and 86. Okay, again you have this mu and sigma. You have now two values of x. X1 is 70. You find the corresponding values of z, corresponding value of z, which is with respect to this x equal to 70, and similarly also find the value x86, which is again 2.3833. Okay, find the corresponding z values. After finding the corresponding z values, go to the table and find the values which are related to the 0.56 and 2.33. Here you will get 0.5, and this is the correlation of 0.5 and 0.06, and you have a value 0.7123. Similarly, from 2.33 you will get this value, okay, 0.9901. These are basically two values. One is this one and one is this one. So now you have this curve and you want to find this value. What you will do, sorry, again my time is not that much good. So you have to find the probability that z is less than 2.33. You have to subtract the other value from this one. Z is less than 0.5. Okay, so you have find this value from the table. You have also found this value from the table. Subtract one value from the other, and it would be the probability that the marks are lying between 70 and 86. Okay, so let's see here. This is in random variable, and you can see that this is the probability. You have to find it. You have found these two values here again, and this is the probability. Okay, you are asked to find. So these are basically A, B and C portions of these questions which you are asked to find the probabilities of. Okay, so I think this question has told you the significance of using the z value instead of the actual equation of this normal random variable. So this normal random variable is very important, and there will be a question in exam from this portion as well. Actually, in many countries and many courses, there is a separate course of normal random variable in which different scenarios are taught, but we are discussing it in our course here. So what did we discuss today? These are basically the three scenarios that when you are going to find the less than value, you will just find a value and it will be equal to less than. Okay, if you are find the value which is more than some z value, then what will you do? You will find the customary method. You will use the customary method and find the value which is less than this z, and then subtract it from 1. Okay, if you want to find out the value which is between 2 points, and to find the values which are between 2 points, you have to find first value and second value and subtract it from the other value as well. Okay, so this is the summary of this overall lecture and overall example which we have discussed. Okay, so this is all about the random variable. There is another theorem after the random variable or normal random variable. There is a theorem which is called central limit theorem. What is a central limit theorem? This theorem has a significance in sampling distribution. So where is it used? This basically shows you that if you have different samples, if you are getting different samples from a certain population, and you have to find the mean of all those populations. Okay, you have different populations. Let me tell it to you. Okay, you have a certain distribution, this one. Okay, it has certain expected value or average value mu. Okay, after it you want to find a certain sample out of this distribution, and you plot this, and you get certain mean value, which is m1. You get another certain samples out of this population. Again, you plot it, and you find another mean value, which is called m2, and so on. You are getting some number of populations. Let's say this is nth population, and the value of the mean here is m of n. Okay, so you have got different mean values of different samples, which are basically the subset of this actual population. Okay, you have found out different means, and you have got it here. So after getting all these values, what will you do? You will plot these mean here, and you will see these all mean. This is the plot of all these mean. m1, m2 up to mn are plotted again, and you will see that the distribution, it will always be a bell curve. This is called the central limit theorem. Okay, it will also be a bell curve, and this is the central limit theorem. This is the concept. I have told you the concept, and let's move on to the slides. Suppose you want to find the distribution of IQ of fresh university students in Pakistan. Okay, this is the overall population. This is the black curve which I have earlier shown you guys. Suppose you want to find the distribution IQ of fresh university students in Pakistan. It is not possible to find the IQ of each and every student and then plot this distribution. This is the actual problem. Okay, you cannot find the probability of certain thing from or the age of every person on earth. So or the habits of the every person on earth, or the coronavirus test result of every person in a country. So you find or pick certain people from a population, you test them, and then say that this is the percentage of this the disease dispersion. Okay, how much the disease has been you can see that has been dispersed or appeared inside a country. So this is the percentage of this dispersion. So it is not possible. So what will you do? You will therefore select a number of students from different universities, which is called a sample. Okay, let's suppose we randomly choose students from 40 different universities across Pakistan. Let's further suppose that we choose 500 students from each of the 40 universities. Out of those 40 universities, you select 500 students. We then find the mean IQ of each sample. Okay, in each 40 universities we have 50 students, and in each 40 of those distributions we get the mean IQ. We then organize the mean of these 40 samples into a histogram plot. You again organize the you are organizing the mean of those 50 students of 50 universities. You are now organizing 40 means of those 40 distributions, because all universities are 40 and each university has 50 students. So in each distribution we have 40 points or 40 people. Then the plot we get is called the sampling distribution of sample means. Okay, I have told the same thing in the first slide. The sampling distribution of sample mean has a direct correlation with the actual distribution of the original population. Okay, and this is called the central limit theorem. If you will see the original thing, and if you are seeing the distribution of the mean of the distribution, so it will have a similar shape, and that's why this is called a central limit theorem. So what you guys will have to do, select a large number of samples from the total population. Okay, select a sample size of n number of points, calculate the mean of each sample, plot the sampling distribution of sample means, and then you will get the same amount of that mean. This is enough, and this thing is up to this point. So today we have discussed very important theorems, very important distributions, and the first distribution we discussed is basically the normal distribution, and after it we discussed a very important central limit theorem. And normal distribution we also discussed a z distribution which has the mean of 0 and standard deviation 1. After it we have discussed the central limit theorem, which also has application in probability and random distribution and random variables and statistics. So we are stopping at this point, and if you guys have any question we will discuss it, but it is not only limited to the theoretical concept. You guys should solve all the related questions, all the related examples, and all related exercise questions, and believe me, these two topics are very important in terms of your exam and in terms of your applications of electrical engineering as well. Okay, so work hard, see different tutorials over the internet, and the most important thing is practice the numerical questions which are listed in your book and in different sources. So thank you so much, and I will see you next time, inshallah. Allah Hafiz.